Hello class again and welcome to this particular video, and in here we're going to be exploring interesting parameters that are used to measure various shapes in terms of focusing on measurements. In our previous class we talked about different ways by which units are used to measure a specific quantity of an object. So for example, here we looked at mass, and from mass we're able to know that the unit used to measure mass is called grams. And we looked at volume, and we said that the volume of an object can be measured using a specific unit called liters. And for our specific video now and moving forward, we're going to be looking at the third parameter that we're going to be exploring, and this is going to be focusing mainly on a specific quantity, which is called length. And length here is going to be measured using the unit which is called meters. And you're going to be seeing different types of meter. Some questions will be like, oh, the distance from one point to the other is some number in kilometers or some number in hectometer, or you can have like centimeter, or you can have the millimeter, and all these different types of prefixes based on the powers of 10 for meters are the things that we're going to be looking at, in terms of various questions that are going to be coming up. Now, take note that the focus of our video here is going to be looking at a specific shape here, and this shape is quite unique and wonderful to explore. I know it's wonderful, and this shape here is called a circle, and this circle as a shape has, of course, is a two-dimensional shape. The three-dimensional form will be called a sphere, and this can be applicable in all areas of your life. You can actually have rings as an example of shapes. You can have streets that maybe has a circular path, or an object moving at a circular path. All these are great illustrations of how circles not only applies to various objects but behaviors of objects. Like for example, Earth orbits around a specific body. Now the orbit might be kind of distorted in a way, but in general it is having a circular path. And so a circle is going to be our focus for this particular unit, and we're going to look at various ways by which you can measure the length from a circle. Now, first is first, we are going to be looking at one particular path where we're going to start at a particular point on the circle outer part and make a round trip around along the red line. So what we're seeing here is an object moving around in this particular circular path from start to the end point. So it started at the dot and it goes around and stops at where it started. Now this distance made from this dot all the way around to the end point is called what? The perimeter. And so the perimeter is the outer distance or the outer length of a whole shape, and you can see that in rectangles or in parallelograms you have, for quadrilaterals we have four sides, which means that the length of all four sides, if you add them together, that gives you the perimeter, because you're considering the outside and not lines inside the shape. So the outer part of a shape is called the perimeter based on the length. Now in a circle we also express perimeter as a familiar term, which is called the circumference. And the circumference, take note, see, fence is called the outer and circum is like a circle. So think about it that way. So the outer side or the wall that is like a circle is called the circumference, and that is how I kind of remember that term. Keep that in mind. So a circumference is the total distance around the circle, or you can say is the total distance outside of this particular shape that makes the shape what it is. So That is one thing to keep in mind. Now, the next one here is that we're going to have a point here. And this point here is highlighted as blue, and it is going to be termed the specific region where if you put a particular, I would say, thin object balanced on it, this particular circular shape doesn't tip over. So it's like, for example, I'm finding the center of mass or gravity where I'm balancing this object to the point where it doesn't fall over. That point is, in this case, if you have an equally distributed shape, you should have this particular point established as what we call the midpoint. And from the midpoint, we will be able to determine other length of the particular shape. So in here, we've already discovered length 1, which is called the perimeter. So we're going to look at another length, and in this length, we're going to start at one end of our circumference, and we are going to go to the other end of the circumference. Now, take notes here that this line that has two arrows on both ends, heads, they touch at a specific point. That point is the midpoint. Take note of that. For this line here to be established as one end exactly to the other end, not like this, not like this, but exactly like this, it is called the diameter. So the diameter of a specific shape is considered to be the distance from one end of a circle to the other end of a circle touching the midpoint. Keep that in mind. And finally, here is another parameter, and this parameter comes from the diameter, and in here the length is starting from the midpoint, and from the midpoint you are going to be going to the other end of your circumference. So it means that in theory, which means that practically speaking, if you have a perfect circle where one side is not equal, or where one side is equal, sorry, to the other sides of the circle, not kind of like an oval type of shape, we should have indeed this diameter to be equal to half of it to be the brown. So it means in here that half of the diameter is equal to the brown line that we see right here, and this brown line is considered to be called what? The radius. And so the radius, take note, it is half of the diameter. I'm going to hopefully fill this in, divided by 2, and therefore we are able to not only find the relationship between the diameter and the radius, but also knowing that the radius is indeed half of the diameter in this case. So take note that these two here, they are, in this case for radius, is the third length that we've actually discovered, and our specific second length in here is called the diameter, and they all come from the midpoint of a specific circle. And the circumference down the road, we're going to be able to determine what the circumference of a circle is based on the radius, based on the diameter. You're going to be giving questions on Hapara where you're going to be exploring what are the different scenarios that fits into what is a circumference or perimeter, or what is the diameter, or what is the radius. So for example, you might be asked that, hey, the radius of a specific object is 2 meters. On a shape, where is the radius? So you should be able to draw a definite radius the way I did right here. And if you ask, for example, that a boy or a girl or any person makes a trip around a specific circular track that is measured as 70 kilometers, what is the region on the circle that indicates that particular situation? You should know that in this case, it is the circumference, which is in this case highlighted as the green path of your specific shape. So I hope you found this really informative. Let me hear your thoughts about this. By that way, I can talk to you soon. On our next video, we're going to talk about how to determine circumference and perimeter and radius using a specific interesting constant that has gone through a lot of research over billions of years. I'm just kidding, thousands of years, and where we are at right now. So all the same, thanks for following me through this. I appreciate it. See you on the next one. Stay smart as always and believe in yourselves.